Today we're going to be working on note card 8, which is called Instantaneous Rate of Change. It so happens that this ties into what we did at the beginning of the year when we had this calculus roller coaster, remember that? And what happens is, in fact, in our last note card we talked about, I think, the average rate of change. What happens, the slope of the tangent line here is what we call the instantaneous rate of change. Yeah, I'm going to just go ahead and abbreviate rate of change, okay? Instantaneous rate of change. So average rate of change, so the instantaneous rate of change is the slope of the tangent line, so it's the exact. Remember yesterday we had the table when we were estimating the population growth in 1870, I think it was? That was using this kind of thing. And so we were estimating f prime, and that's another thing we can call this. Sometimes you'll see this as f prime of x, that prime being, you remember I mentioned that yesterday? And so we can use an average rate of change to estimate an instantaneous rate of change, but today is when we really, for real, do the actual calculus. That's what this is. What it is, f prime of a value, in this case they give a, is, and so you'll see this f prime of x, you'll see a lot of times written as, in this form here, is the most common one, except you'll see x instead of a here. And so this is the one I'm circling here that you're going to see that comes up again and again. So you have to realize that when you see this form of h here, that this is the f of x we're talking about. And that when we solve all this and find the limit as h approaches 0 of all this, that is equal to the exact instantaneous rate of change where x equals a in this case. Okay, so they're using a for a specific value, but we usually see this as f prime of x equals f of x plus h minus f of x over h. And then it says right here that if you have an example, a change in position, and we're going to see a specific problem about that with respect to time, will be instantaneous velocity. So we're going to go over some specific examples of using this. And we're given this problem right here, but I'm going to give one that's a little bit different than that. This one here is more complicated than I want to do. I want to say it's the same thing, instantaneous rate of change at x equals 2 is given by, for f of x equals x squared. All right? So we're going to use the definition of a derivative, which is f prime of x equals the limit as x approaches, as h approaches 0 of f of x plus h minus f of x all over h. So we want this to be nailed to your consciousness, and this, like I said before, is really where, for the first day, the things we were doing up till now, the limits, continuity, average rate of change, that's sort of all building up to the actual calculus is what we're doing today. So this is real calculus. differential calculus. So now we're going to use this formula. What we're going to do is we're going to find f prime of x. We're going to find a function for f prime of x, and then we're going to plug in 2 for that function. Okay. So now I'm going to show you that in case. So f prime of x. Okay, this is going to be for f of x equals x squared. Just to be clear about that. What it is, it's going to be the limit as h approaches 0 of, and f of x is x squared, right? So we're going to write, in the place of x, what are we going to write? X plus h squared. So that's f of x plus h minus, we're going to have x squared, because that's f of x, all over h. Now, I hope you can see right now that if we plug in 0 for h, what do we have here? Well, we'll have x squared minus x squared, which is 0, right?
Over 0.
Over 0, which is bum, bum, bum. That's not going to work out, right?
More work.
We have more work to do. And so we have to, that's actually what we have to do here. So what we're going to do is we're going to expand all of this out here. And I'm just going to continue writing here, equals limit as h approaches 0 of, we're going to expand all of this out here. So what's the expansion of this thing right here?
X squared.
X squared
And then would it be 2
plus 2 xh
xh
plus h squared,
over h?
and then we're going to subtract x squared here, and then that's all over h, right?
Yep.
And then what do we notice happens here?
X squared's canceled.
X squareds will cancel each other out. Okay, so we have that. And so what we're left with is limit as h approaches 0 of xh,
Should be 2xh.
2xh, thank you for catching that. That's important to the deal. 2xh plus h squared over h. Now what happens now?
You can factor out an h.
So you can factor out an h, but really it's simpler than that.
Oh, is it?
What it is we have 2x h divided by h is
2x.
2x. So we're going to have 2x, and what's h squared divided by h?
H.
Plus h. And now, when we plug in, I won't even do it to the right. Now when we plug in 0 for h, what do we have left?
2x.
2x. And so this is going to be f prime of x. Okay, so that's f prime of x. And then we can finally go back and answer the question up here and say, okay, what is f prime of 2? Because that's what we want, at x equals 2. So f prime of 2 is equal to 2 times 2 is equal to 4. So that is our answer. That is our f prime of 2. That is our instantaneous rate of change. That's what it is. Yes, sir. Go ahead.
So forcing instantaneous rate change?
So that's that. Now what I'm going to do is I'm going to give you another problem that's similar to work out, have you deal with that. I'm going to say it's going to be the same type of situation. We're going to say find f prime of x if f of x equals 3x minus, no, I'm just going to keep it 3x. If f of x equals 3x, find f prime of x and use the definition of derivative. You might need extra paper for that. Does anybody need extra paper? Gavin, you need extra paper to write on? Kylie, you need extra paper? Because the thing about these things, the way you do them is that you just write a lot. It takes a lot of writing to do this. Have you finished? Yeah. Gavin, have you finished that? Okay, so f prime of x is equal to limit as x approaches h of f of x plus h minus f of x over h. Actually, I got this wrong. As h approaches 0. Okay, so this is a standard thing here. So for our particular situation here, we're going to say limit as h approaches 0 of, we're going to have f of x is going to be 3 x plus h, right? Minus 3x over h. Are we okay so far? And then that's going to be equal to limit as h approaches 0 of 3x plus 3h minus 3x over h. What happens here?
3x is canceled.
These will cancel. And so this is going to be equal to limit as h approaches 0 of 3h over h, and that's going to be equal to limit as h approaches 0, and what do we have left here?
Just 3.
3. So as h approaches 0, what is this thing equal to? 3. So our answer to this thing is that f prime of x is equal to 3. Now, if we were thinking up here, we probably already knew that, right? Because what is the slope of a line? It's just it's the slope, it's the coefficient of x for a linear situation. So that's just a simple example showing this. Now I want you to try another one. And I'll give this to you. Find f prime of x if f of x equals 2x cubed minus 4x. Now this, what you're going to have for this, you're going to have a cubic expansion. And one thing we did last year is we talked about binomial expansions. So this is what a binomial expansion to the third power looks like. You remember doing that last year? Gavin, you're working on this? Oh, attendance. need some extra paper?
Okay. I have it written down or something.
What you're gonna find out when you do these things, when you work it out right, most of the stuff will just cancel out. And then you're left with a pretty simple thing. And if stuff doesn't cancel out all over the place, there's probably a mistake you made somewhere.
I don't make a mistake anyway. It's just like a lot.
Yeah.
I don't know where everything I have
Just throw it on the end, because.
I will tell you one thing that we have is that shortly, probably tomorrow, you're gonna see some shortcuts for this.
Nice.
So
On the test we're taking Tuesday, is it just about the limits, or is it gonna have some of this?
limits and continuity.
Okay, great.
Yeah.
Great, because I don't have.
Yeah, because we're gonna have one integral from something to something where we do that, and I'm gonna say that, yeah, so that'll be it.
I'm cool with the limits and continuity, but I don't have a grab on this yet, so.
That's right, this is just, again, this is the first day,
We're just guessing at this point.
we actually do, yeah. Okay. So what we have here is f prime of x is going to be equal to limit as h approaches 0 of this function here to, we have x plus h cubed minus 4 x plus h.
Oh, okay, that's what I did.
Okay. Then we're going to be subtracting this whole thing here. So we have to subtract f of x, which is subtracting 2x cubed minus 4x all over h. Okay? And then we expand out everything, and I'm going to leave myself some more room over here to the left because that's going to be a lot of writing across here. So I'll put equals limit as h approaches 0 of, we have 2 times, we're going to have x cubed, and using our binomial expansion, we're going to have plus 3, we're going to have x squared h plus 3 x h squared plus h cubed and then it's going to be minus 4x minus 4h minus 2x cubed minus 4x. I couldn't quite get that in there. And that's all going to be over h. And then I'm going to leave myself even some more room here. Did you get stuff to cancel out all over the place? Anybody who
Yeah.
did this? A lot of stuff canceled out, right?
I mean, I have an answer, but I don't know if it's right.
Yeah, well, that's what we're doing. So I'm going to write out all this. So we have 2x cubed plus 6x squared h. And I'm just distributing this 2 now, right? Plus 6x h squared plus 2h squared, h cubed, excuse me, 2h cubed. And now we have minus 4x minus 4h. And then we have minus 2x cubed minus 4x.
Would it be plus 4x at the end?
That'd be plus 4x. He's right, because what you did is when you distribute that, that becomes plus 4x. Thank you for catching that.
That deserves a
All
sticker.
over h. And then, that's one thing you got to watch out for. Now you see what you can cancel. So we can cancel these guys, right? And we should have a plus 4x and a minus, so that's going to cancel that. And everything else in here has h in it, right? Okay. And I don't know if we could combine like terms, but I don't think I see any like terms.
I don't think
These are all different. So I'm just going to rewrite all this. Limit as h approaches 0 of what we have left. We have 6x squared h plus 6xh squared plus 2h cubed minus 4h, and all of that is over h. And now that's going to be equal to a limit as h approaches 0, and then we cancel stuff here. So if we divide this here by h, what do we have left?
it's just
6x squared. And then here we have plus 6xh, is that right? Plus 2h squared minus 4. And now when we plug in 0 for everything, we get, for h everywhere, we get 6x squared plus 0 minus 4. So this is what we have left. F prime of x equals 6x squared minus 4. Okay?
I did it.
You did it? You see?
That's crazy, Mr. G.
Okay. But you see that stuff cancels out all over the place, and the stuff that doesn't cancel out, when you plug in 0 for the h, that makes this stuff go away too. So all you have left is 6x squared minus 4. And do you remember the last one here we did? If you just take this piece right here, what is the slope of negative 4x? Negative 4. So you can kind of see where that came from, can't you? Now, what I want you to do
Are you doing another one?
is they kind of messed up this one. I want you to do this one right here, and we'll probably they kind of messed it up because it's not this is supposed to be meters actually. It's supposed to be meters because that's the standard. So I want you to do this one right here, and so that would be probably where we end up using a definition of a derivative. And again the binomial expansion. If you have quantity a plus b squared, that's going to be equal to a squared plus 2ab plus b squared. what I want to do at the bottom here is I want to put down S prime of 4 is equal to negative 14.2. So I just leave that as a marker there to check your work when you get down to that, okay? And it's going to be 14, let's see your feet per second, it'll be S prime of t. This is going to be feet, no meters. Yeah, we change this to meters. Meters per second. Okay, I'm going to start writing this out. S prime of t is equal to the limit as h approaches 0 of, we have negative 4.9. We're going to have, I'm going to use t plus h squared plus 25 t plus h, and then plus 3 minus all this, negative 4t squared plus 25t plus 3. Okay, so minus all that, and all of this is over h. And so what you're going to have is limit as h approaches 0 of, you're going to have negative 4.9 t squared, and then you're going to have 2 times t times h times negative 4.9, so you're going to get negative 9.8 th. Is that what you got?
Yes.
Minus 4.9 h squared plus 25t plus 25h, and then you're going to have plus 3, and then you're going to have plus 4.9 t squared minus 25t minus 3, and all this over h. And so now you cancel out what you can, and this will cancel that. What else cancels?
The 25t.
25t and minus 25t.
Minus 3 plus 3.
Minus 3 plus 3, good catch, good catch. So now that's going to be equal to a limit as h approaches 0 of negative 9.8 th minus 4.9 h squared, and then we'll have plus 25h. Is that all we have left? That's it, right? Just those three things. and all that over h. So that's going to be limit equal to limit as h approaches 0 of, we cancel out, we have negative 9.8 t, is that right? And then we have minus 4.9 h plus 25. And then when we plug in for h, what do we get? Let's see, is that right?
Yeah, that's right.
We get negative 9.8 t, is that right?
Yes.
Plus 25. So that would be it. And so when we plug in 4, s prime of 4, we get negative 9.8 times 4 plus 25. And what does that equal to?
That.
Negative 14.2 meters per second. So really that's it. And we're going to continue working on this a little more tomorrow. And we're going to get, probably tomorrow, we'll get to our shortcuts on this. Okay?
So you can use the prime of the function to find the instantaneous rate of change anywhere?
Yes.
Oh, that's crazy.
Yeah, so it's a crazy tool of tactics. So what it is, when you understand what that is, that's what makes calculus such a powerful tool.
And the instantaneous rate of change is just the slope at a point?
Yes, that's
Oh,
right.
that's bonkers.
It is. And it's the greatest innovation that makes civilization as we know it essentially possible.
Calculus makes my brain hurt.